Expansion and contraction. We are surrounded by solids, liquids, and gases, and they all warm up and cool down from time to time. When they warm up, they expand. When they cool down, they contract. Sometimes expansion and contraction are useful. Other times, they are a nuisance. This bridge is made of solid steel with a solid surface of concrete. During the summer, the surface of the bridge heats up. The surface expands. When the surface gets bigger, what will happen to the bridge? If measures are not taken to allow the bridge to expand, it can buckle and break, or the force of expansion may damage the steel structure. Bridge engineers design the bridge's surface in sections. They place expansion joints where the sections meet. The bridge shown here has expansion joints with steel fingers that can move between each other. When the surface gets hot, the sections get longer and the fingers push between each other. When it gets cold, the sections get shorter and the fingers pull apart. The fingers design allows cars to cross the junctions between the surface sections smoothly. This bridge has finger-type expansion joints between sections of its surface. On a cold day, the bridge surface contracts. The fingers of the expansion joint don't overlap very much when the sections are short. Thermometers are filled with liquid. The most commonly used liquid is alcohol. When the alcohol gets hot, it expands. When the alcohol gets cold, it contracts. Expansion and contraction of alcohol are useful properties for making a thermometer. Here's how it works. If you want to know the temperature of the water in a vial, you place the bulb of a thermometer in the water. If the water is cold, heat moves from warm thermometer bulb to the cold water. As the alcohol cools down, the kinetic energy of the alcohol particles declines. When the alcohol particles move less, they move closer together, and the alcohol contracts. When the alcohol contracts, it takes up less space inside the thermometer. The level in the stem goes down. When the thermometer is moved to a vial of warm water, the alcohol in the bulb heats up. The kinetic energy of the alcohol particles increases, and the volume of the alcohol expands. The larger volume pushes farther up the thermometer stem. By using the numbers on the thermometer stem, you can compare temperatures. These thermometers are calibrated in degrees Celsius. The cool water in the picture is about 16 degrees Celsius. The warm water is about 51 degrees Celsius. A thermometer contains alcohol which expands when it gets warm and contracts when it gets cool. The height of the alcohol column indicates the temperature of the bulb around the thermometer bulb. Did you ever see a container of fruit salad open itself? Here's the chain of events that can make that happen. You mix up some grapes, strawberries, and melon. You eat some of the salad, but there is some left for a snack later. Snap a tight-fitting plastic lid on the container of fruit salad and pop it in the refrigerator to keep it fresh. Later, you take the salad out of the refrigerator and set it on the counter. If you don't open the container right away, in 10 or 15 minutes, the lid pops off the container, reminding you to enjoy your snack. Why? The air inside the container is gas. As the container of fruit salad warms up, so does the air in the container with the fruit. The kinetic energy of the air particles increases and they push harder on each other and on the lid of the container. If you look closely, you can see the lid bulging as the air warms. Eventually, the pressure created by the increased kinetic energy of the air particles will pop the lid right off the container. Expansion and contraction occur around us all the time. Air expands and contracts as it warms and cools. We don't see it happening, but we see the results. Weather, particularly wind, happens as a result of expanding and contracting air. Have you ever been in an old, quiet building when there's sudden creaking or cracking sound? Is it a haunted house? Probably not. Buildings expand and contract when they heat and cool. When they do, beams, walls, and roofs move a little bit. When parts of building move, they can make sounds. Listen closely next time you are in a quiet building just after sunrise or just after sunset. Those are the times when you are most likely to hear unexpected sounds. Do you know why? Train tracks are steel. Tracks expand when they get hot in the sunshine. What keeps them from buckling and bending? Expansion joints. Next time you are close to some train tracks, look for the expansion joints. What keeps sidewalks and roads from breaking and buckling? Expansion joints. These joints are spaces between the concrete sections. The spaces are filled with material that can compress when the concrete expands. Keep your eyes open when you are looking at very large structures and huge expanses of solid surface. If you look closely, you will probably see how the engineers solve the problems presented by expansion and contraction caused by heating and cooling.